My name is Dr. Manoranjan Oja. I am the Assistant Professor, Department of Basic Science, Chemistry, SR University. Today our topic is luminescence in the materials. So we'll discuss here the luminescence property of the materials, how it works, what is the mechanism, and which materials can be used for the luminescence. We'll discuss that what is the luminescence property. So in simplest way, we can speak that luminescence property is that light emitting property of a compound. So means what happened that let's say one material is exposed to a different kind of energy. After taking that energy from outside, the electronic transitions takes place inside the compound. Then this higher energy inside the compound will be lowered by emitting the light as energy. So this when compound is having this kind of a light emitting properties to come to the excited to the ground state, we call the luminescence property. So what we are discussing this property is that the material is exposed to the light, so it is gaining the light. So then after that, when the energy or electrons in the ground state is going to the excited state, and this excited energy of the electron is released by emitting some kind of a radiations or electromagnetic radiations or light, then we will get the luminescence nature of the material. So inside the compound, there will be a electronic transitions. That electronic transitions will happen from the higher energy state to the lower energy state. So when we'll observe this kind of a property, we call that luminescence property. So this property can be observed for the gases, liquid or solid. On all cases, we can observe these properties. Right. So this property is very essential for the very important process or properties of the compound, which is used for modern technology such as for lighting, display systems, laser or sensor, or medical imaging or security features. This compound has been used for this purpose. So that's why we'll discuss that what is the mechanism, how exactly process happened in the case of the luminescence of the compound. The process is taking places here. That first what we are doing is that so we are using an energy source, that is a light. So we are using one energy source, that is a light, that may be ultraviolet light or electrical current or chemical reactions or mechanical states, that from the outside we are using as an energy source. Right, that energy source we are providing to a materials. Then when the materials will receive that energy, then what it will do, it will elevate the electrons from the lower energy state, ground state, to higher energy excited state. For example, here if you see, this is one electronic state S1, S0, this is another electronic state is S1, and another higher energy state is S2. In the S0 electronic state, there are many vibrational states there. These are small, these are vibrational state, and this is for total is one electronic state. And like this, here also one electronic state, and this is one electronic state. Now, when we are providing the energy, that is in the form of ultraviolet lights or electrical current or chemical reactions or mechanical states, then the electron in the ground state or ground electronic state, they will gain the energy and will elevate to the higher energy state. So maybe from S0 to S1 or S0 to S2 in different vibrational level. So after when electron will come to the higher energy state, then they can release the energy, or they want to come to the ground state. Then it can come in two different ways. One is that, let's say it is coming to the higher energy state, then it can release energy. Then can come same electronic state but in different vibrational level. This is called internal conversions. When same state is there, but that vibrational level, that electron state is coming, that is called vibrational levels. It is in the same electronic state, it is coming, we call the internal conversions. Now that can be happened that by using the non-radiative decay. The non-radiative decay means this, when this kind of a for same electronic state and electronic transitions are happening with a different vibrational level, then it may be in the means of heating, the energy can be released. So this process is called non-radiative decay. Means not like a light, it is not emitting. But when from one higher energy state to lower energy state, when it is emit, that in the radiative form, then this process we call is the luminescence property. So for example, S0 to S1 some transitions happen, and let's say S0 to S2 happen. Or in S0 to, let's say, S0, the vibrational level, higher vibrational level, the transitions happen. Then from this one, it may come to the lowest vibrational level. This process is non-radiative decay or non-radiative relaxations. Then after that, from here, radiative decay transitions happen. So this is called luminescence property. This is called internal conversions. So inter-system crossings may also happen. For example, this is a singlet state energy state, and this is the triplet state energy. So from singlet to triplet, energy transfer can, or electronic transfer may happen. This process is called inter-system crossings. So now, when from one electronic state to another electronic state, when the emission takes place, or we can say from higher energy electronic state to ground state, when transitions happen, then this process is called the emissions process. And the emission process, if it is luminescence property, then the radioactive radiations should emit. So that process is called luminescence property. So based on the different type of energy gap and the time or which compound is sourced, so different kind of luminescence properties we can observe in the material. So we can classify it in a different way based on the which means how that electronic transition is taking place, by the means of that from outside what we are providing the energy for transitions of the electron from the ground state to the excited state. For example, let's say we are providing the energy from the photons, means we are using a light source. That light is absorbed by the material, and this electron in the ground state is takes that energy and promoted to the excited state. When it comes to the ground state, then it emits the radiations, then we call the luminescence property. If it is done by the source of the light, maybe it is ultraviolet or visible light, so then this process is called photoluminescence. Means we are getting the luminescence property only the presence of the photon or light. So this process is called photoluminescence property. It is being used in the fluorescence lamp or optical sensing device. So in fluorescence and photoluminescence, we'll discuss later on that what is the fluorescence. There is two type of the process is called fluorescence and phosphorescence. Based on the time this radiations happen, electromagnetic radiations happened with this time period. Based on that, there will be different type of the photoluminescence, that is called fluorescence or phosphorescence. We'll discuss later in this section. So another part is called the electroluminescence property. In the electroluminescence property, what we are doing, we are exciting the ground state electron to promote the electron into the higher energy state or excited state in by the means of the electric current or electric field. Then when you will get the emissions property, we call the electroluminescence property. So it is being used for LEDs or OLEDs, for electronic display panel. This for this purpose it is used, and it is for it is very high efficiency and low energy consumptions. For this material it needs very low energy, so energy consumption is very less. So another one type is called the chemiluminescence. What is chemiluminescence is means, so some chemical reactions is taking places. So that due to the chemical reactions is taking places, then this light emitting property or luminescence property is observed in the material, that is called chemiluminescence. So luminescence properties is happening in the molecules due to the chemical reactions. So this is called chemiluminescence. So for include the glow sticks or biochemical detection method, or means for external light sources is not, we are not using any external light sources. So in the reactions medium itself, due to the reactions, the luminescence property is observed. So another luminescence is that bioluminescence. Bioluminescence is a natural property which happen for living organism, that naturally for many bacteria or fish, for example jellyfish, fireflies or bacteria, they have this kind of a behavior that it will emit the lights. So that process is called bioluminescence. In biological molecules, biological organism, we can see this kind of the behavior. So this is called the bioluminescence property. Now thermoluminescence is the luminescence property when we observe, that is due to the heating effect. Means when a higher energy molecule is heated, then it emits the light, then we will get the luminescence property. As we are getting the luminescence property due to the heating or thermal reason, thermally, so this process is called the thermoluminescence. So it is being used for archaeological age determination process. And another one is called triboluminescence. This is the mechanical process. Due to the mechanical process, when you will get the luminescence property of the materials, we call the triboluminescence. Just kind of a crushing or rubbing or fracturing the materials. For this chemical, mechanical, when we are doing this, then we are getting the luminescence property of the materials. So that is called the triboluminescence. Now, based on the emissions type, means let's say one materials what we have, let's say this is valence band and the conduction band. So now from outside we are giving maybe ultra UV light. So then electron from the ground state going to the excited state, then again it is emit. So due to the emissions we are getting the light luminescence property. So that is photoluminescence, because we are using the photon here or light here for the excitation of the electron. Now question is that when we will see the two kind of the behavior of the materials. One is, as long as we are providing the light or energy source or UV light or photon, then what happens is that as long as that source is available, then we'll see the emissions behavior or luminescence behavior. When we are removing the light source, then the full luminescence properties is instantly stopped. So when this kind of the behavior happen, we call the fluorescence property. Means we are exciting the electrons, then when it will come to the ground state, we get the emissions and luminescence property we observe for the material. But how, when we are getting this luminescence, as long as we have the energy source, that UV light source. When we are removing that UV light source, then emissions instantly stopped there. So you can say within the nanoseconds limit. So this process is called fluorescence property, right? So means we can say when we are removing the light source, energy source or light source, instantly or immediately this luminescence property of the material is stopped. So this kind of behavior you can observe for fluorescence lamps or dye or certain minerals also it is observed. So you can say that, let's say we have excitations of the materials. Due to the excitations we are having the luminescence property, but instead when the source of the light is available, that time we will see the luminescence. When source of the light is removed, then luminescence property is stopped. So this is called fluorescence property. Another is called phosphorescence property. It's the same thing we are doing, but emissions we are coming that is delayed. Means after the removal the light, that still we are getting the luminescence property. When we are getting this delayed or after the removal of the UV light, when still we are getting the luminescence property, then process is called the phosphorescence property. So this duration may be milliseconds to several hours is happened. Means let's say we are providing the UV light source for energy excitations, and after removing this one, even for 1 hour we can get the luminescence property of the materials. So this process is called phosphorescence properties. So it can be used to glow in dark materials, and emergency sign for this one we used for the phosphorescence material. So based on the emissions time, when the emissions is coming, how long it is coming, based on that materials can be classified, or photoluminescence property can be classified into two ways. One is fluorescence and phosphorescence. Now what are those materials can be used? These properties can be observed. What are the different type of the materials where this luminescence property can be observed? One thing called is the inorganic materials. So what are the inorganic materials is being used for the luminescence property? That compound is called zinc sulfide. This is a well-known compound for inorganic luminescence material, that is called zinc sulfide. So and rare earth dot phosphor also can be seen that having the luminescence properties. So this what these materials exhibit, that if you heat it is a material, because this material is having means this zinc sulfide or some kind of a rare earth dot phosphor, they have a high stability, that is called thermal stability. Means at a high temperature it can sustain. These are the high stability of the materials, and also this can be used for the long run. So means this decay or performance degradations is not happened for a quick period of time. So it can be used for a long period of time, and it is being used for the display of the device, lasers, or lighting system as well. So these are the inorganic materials can be used. Another is organic luminescence material. This category includes organic dyes or conjugated polymers. Means what here we are using organic compound we are using, and that can be having the luminescence property, because that in organic compound what we have in our hand, that we can modify the structure, or we can extend the structure properties, or we can introduce some kind of a functional group. So as we have a flexibility in structure modifications, then its light emitting properties also will may change, because due to the functional group or structure modification, the energy gap or band gap of this molecule can be changed. And when it will be changed, then as band gap is changed, so radiations absorptions or the light absorption property also will change, also emissions property also will change. So that's how it is much more better than that of the inorganic compound, where in the where you can much more modify the compound structures, or you can manipulate the band gap in that sense. and it is extensively used for OLED display and organic sensing applications. Right. Another is semiconductor luminescence material. So semiconductor compound can be seen having the luminescence properties. For example, gallium arsenide or cadmium selenide. So this semiconductor means this energy gap between the conduction band and the valence band is less energy or in intermediate energy gap, that is maybe up to 3 electron volt. For that, that can show the luminescence property. This is for example cadmium selenide or gallium arsenide. So this has been used for LED as well, or laser diode or quantum diode dots. Also, this has been used. No, where the this applications of the luminescence property has been just now we discussed for lighting. For example, there is fluorescence light or LED or phosphor-based lamp. This has been used. The property is used, that is called luminescence property. Or display technology for televisions or smartphone or monitor or OLED panels. This also has been used, this property. Medical applications for bioimaging or disease detection, diagnostics markers. It is also has been used for security, anti-counter rating and ink or currency authentications, or that one also luminescence property of the material has been used. Environmental monitoring, detections of radiations and pollutant, or scientific research, spectroscopies, analysis, and material studies. These are the sector or the sector where, or the field where this luminescence property has been used. What is the advantage of this material to be used? So these materials, when it shows the luminescence property, these are very high energy efficiency. High energy efficiency means that whatever we are providing the energy from the outside, and how much we are getting energy from the materials, that is called the efficiency of the system. Means if we are providing the materials that energy we are providing, and we are getting back that energy, if it is similar or closer to same, then can say that we are losing the less energy. Right. So that's what this materials when it shows the luminescence property, that we are losing very less energy. That's what is called the high energy efficiency. Means whatever that we are providing the energy due to the luminescence, or when it emits the light or emissions is taking place, that similar energy we are receiving it. So absorption process, whatever the energy is provided, for emission process, similar energy we are getting. So energy loss is less. So that's why it is called high energy efficiency. Low heat productions. For high energy efficiency, because this reason we have a low heat productions. For example, let's say this is our ground state electron state, that is S0, and this is S1. Let's say this is S1. Now here one electronic transition is takes place up to here. Now from here to here, this is called, this electron from here to here, this high energy state to this high energy state, electron comes. Then this emissions of this energy, that is maybe for non-radiative, that is maybe in the form of heating, and after that from this part to this part, this emission is taking place. So if you see, maximum is the radiative decay, but radiative transitions, and very small part, this small energy is for the non-radiative transition, that is maybe using for heat productions. So heat productions, it is utilized very less, whereas the radiative transition is taking place is more. So that's why when high energy efficiency happen, so this low heat productions of the heat will be always low. Broad range of the emissions color. So that means you can change that the band gap, so that can this emissions also can happen with the emitting in a different kind of a light. So you can get a different kind of a range that for emissions color. Eco-friendly alternative to conventional lighting technology, because it is a very high energy efficient, so that's why it is a it is alternative or eco-friendly also, and conventional lighting technology, where energy we use for this conventional lighting technology is much more higher than that of the this luminescence property of the compound. So these are the advantages of the materials. Now, what are the disadvantages of the materials? One disadvantage is called degradations. Degradations means whatever the materials we are using, the structure may change or the structural stability of the materials is changed over the time. If the structure of stability of the material is changed, then the band gap also will change. So luminescence property of the material also will change. So this is one limitation, that is we need some compound that should be highly stable, so that you can get the luminescence property of the material for over the long period of time. Otherwise, this material functions or its efficiency will decrease over the time. Second thing is the sensitive towards the environmental factor such as temperature and moisture. It's related to the stability of the material as well, because the compound when you will use, that also may affect its functions due to the temperature or moisture. So due to the temperature, maybe this electronic transitions will takes place, it will change, and the moisture also it can function as the properties stability. So that's why it is very sensitive maybe to the environment, where the temperature and moisture can play a role for its stability. Now, that complex and costly synthesis of the process for the advanced materials. This is very important. That let's say we are making some quantum dot molecules, or the OLEDs, or for the luminescence compound. Now, these materials, how easy we can make it? If it is very easy to make it, then it has very unique applications, or the cost of the material will be reduced. But if it is very costly, the synthesis process is costly, then overall cost or the overall cost of the materials will be very high. So in that case, it cannot compete that normal conventional lighting systems. So that's why if the synthesis process is very complex, or the synthesis process is costly, then we have a problem to utilize it in a large scale manner. So these are the limitations of the luminescence property in applications. So now what we are discussed in this courses, that we discussed is the what is the luminescence property. That luminescence property means the compounds having a property which gain energy from the outside, and then electronic transitions happen from the ground state to excited state, and from the excited state, when it emits, the emission process takes place, then it will show the light. So this process is called luminescence property. So molecules or compound or atom, so they are emitting the lights when it is coming to the excited to the ground state. This process is called luminescence. Then what are the types of the emissions? And that is a classifications. We discuss the different type of the classification of the luminescence materials. One is maybe called photoluminescence, thermoluminescence, or different kind of bioluminescence. So different kind of the luminescence we discussed. And then depending on the emissions of the light, photoluminescence also having the different type like phosphorescence and the fluorescence. That photoluminescence with emissions process with different time range, that also we discuss. And also we discuss what is the applications of the materials, which purpose it can be used, and also we discuss what is the advantage of using these materials. For example, this materials is a very high energy efficiency compound rather than compared to conventional light emitting material, light emitting materials. These are very energy efficiency material. Then some challenges also is there for this properties of the material. That is that how easily we can make it, means the synthesis process, and also the how easy we can make it, that is called complexity of the process. So if we are able to make it very easily and very easy way and also less costly, then that will be good for us. So these are the challenges. Generally, these processes are very complex process and synthesis steps are very costly. So these are the challenges for the materials. So we discuss in this parts. Okay, so we'll stop here.